found something to make you be present in the class. Because some of the students just become online and then go to sleep. But when I give these examples, you should write it. Well, first, this instruction run read A. It reads this 500. I write it here. This is 500. Yes, there is a bank account. For example, one user wants to um, take $300 from this account. For example, you are using your card, but you gave a check to another person, so another user is trying to take 400 from the same account. So you have $500 in your account, and two users from different places are trying to take money from your account. And it is legal. It's illegal because you may do something in online, for example, and at the same time, someone you have given a check to someone and go to bank and want to take their money. Then this transaction, um, this transaction, read the amount. It's 500. Here A it reads A and bring it to the working area, working memory, a private memory for this transaction. So this 500 is in hard disk, for example, and here it's just transaction 1 just reads the amount and brings it to the main memory. In the main memory, in the RAM, in a, for example, a variable, we have a variable here. It computes this one, 200. But before this transaction, try to write the results here before it writes the results in the hard disk. Another transaction came from somewhere else. It read A, it's still 500 because the transaction 1 hasn't changed the previous the actual amount of the account. So this transaction reads 500 also. And this transaction doesn't know that the amount is changing somewhere else. Computes this 100 and then writes A. Write A, the new A is 100. This transaction here writes A in the hard disk. So it will change from 500 to 100. After this transaction here, this transaction um, is ending and is trying to write the result here in the hard disk. It has computed 200, so it wants to write the results again. So the value will change again to 200. 200 from the transaction 1. You know what happened? We had 500, we take 300 and 400 equal 700. We take $700 from $500 and we have 200, still we have $200. But this happened because we don't have any management of concurrent run of these transactions. The transactions are running parallel or concurrent and there is no control of this. It doesn't matter. It doesn't matter. There are two transactions. One can be transferring money and the another one can be buying from an online store. You give your card to your friend, to your family, your brother, and he goes to the market, to the store to buy something. At the same time, you are transferring money online, for example. You are going online in your bank account and you are transferring money to someone else. If there is no control for concurrent run of these transactions, there might be some issues like this, some problems like this. There are another examples here. For example, you are buying a ticket. You are buying a ticket from Iraq to Iran. And there is just one place left. You are buying the ticket from an agency or online, for example, and you see the one ticket, just one place in that plane, in that airplane, there is just one ticket, and another person is trying to buy the same place in the airplane. If there is no control here, then the just one ticket will be sold to several persons. So and then you go to the airport and they have they are sold sold the for example they have 300 places in the airplane, but they have sold, for example, 400 places, 400 tickets, and 100% will be there. So there must be some issues here. Of course, it's not related to our course to give you the solution of this, but I will just you know that there must be some luck algorithm here. And the transaction processing, issue is in, for example, database, the advanced database course. I don't know if you have this course to advanced database in the university. Do you have the advanced database or not? But the transaction processing will be referred in that course. But just for your information, any transaction which wants to change data or wants to read the data must lock the information, lock that record. For example, it must here here before it reads the information, the transaction must lock A. Say lock A. Actually, there are two kinds of lock, but I don't want to go to details. There are two kinds of lock for write and read. They are different, but I just say lock. When it locks the A, and then you consider that transaction 1 has started earlier. First transaction 1 and then transaction 2 is coming and running. When first transaction 1 starts, it locks A. And then transaction 2 wants to use the same information and it must lock the data 2.